Industrial refrigeration is a necessity for most food manufacturers. In this video, I will briefly review refrigeration systems and provide examples of recommendations that could increase efficiency and decrease the cost of refrigeration. First, let us review the basic refrigeration cycle. No matter what refrigeration system is used, the refrigeration cycle follows these 4 steps: compression, condensation, expansion, and evaporation. The first step, compression, is performed by the compressor and consumes the most energy. Next, condensation occurs in the condenser, where heat is rejected to the environment as the refrigerant condenses. Next, the refrigerant is throttled through an expansion valve to reduce pressure. Finally, the refrigerant absorbs heat from the cooled area as it evaporates in the evaporator. In real applications, there are many additions and variations to the refrigeration cycle. However, the following 4 recommendations will be useful for most systems. The first recommendation is to perform regular and preventative maintenance. This is the best way to keep your system running efficiently and avoid large costs for major repairs. The following list, made by the U.S. EPA Green Chill Partnership, is a good starting list of regular maintenance that should be done. Some of the most important maintenance tasks on this list are cleaning evaporator and condenser coils, cleaning motor and fan blades with a soft cloth, and having a professional check electrical connections annually. You should also aim to prevent and reduce refrigerant leaks. Refrigerant leaks can reduce system efficiency, harm the environment and employees, cost lots of money to recharge, and lead to compliance issues. According to the U.S. EPA, a typical industrial refrigeration system can leak 20 to 30% of its refrigerant annually. To reduce the amount of refrigerant leaked, consider identifying and logging refrigerant levels, checking compressor racks, piping, and valves for oil seepage, and include other tasks from this list in your regular maintenance. The second recommendation is to eliminate and reduce heat sources entering refrigerated areas. Some common heat sources that can be reduced are lighting and infiltration of outside air. To reduce the heat load caused by lighting, lights should be turned off in refrigerated areas when unoccupied, or occupancy sensors should be used. It is also important to use more efficient bulbs that produce less heat, like LEDs. To reduce infiltration of outside air, keep the number of entrances and exits from the refrigerated area to a minimum. Additionally, make sure that strip curtains, air curtains, rolling doors, or other doorway devices are working properly. A useful free tool to calculate the load on the refrigeration system caused by infiltration is the Door Infiltration Estimator, created by the Industrial Refrigeration Consortium. The link to this tool can be found in the credits of this video. The third recommendation is to modify the refrigeration system to operate at a lower pressure. Many refrigeration systems operate the condenser at a constant pressure that sets the condensing temperature constant at 15 to 20 degrees greater than the highest annual temperature. During most days throughout the year, the condenser temperature could be much lower. Therefore, the pressure could be reduced on most days, which would reduce the work done by the compressor. There are many options to reduce the system pressure. One option is to use a floating head pressure, which adjusts the pressure according to current ambient temperature. The Industrial Assessment Center calculates reducing the system pressure can save $28,840 annually on average, and would have an average payback of 1.2 years. This recommendation would result in refrigeration energy savings of 5 to 12%. One last tip for commercial-sized systems is consider buying Energy Star certified refrigerators and freezers to save money and energy. The Federal Energy Management Program has calculated that choosing an ENERGY STAR certified commercial refrigerator will save between $788 and $1,073 annually, compared to the less efficient models that are not ENERGY STAR certified. Thank you for viewing this video about industrial refrigeration and food manufacturing. For further and more in-depth resources, please follow the links provided in the credit slides.